Hey guys, happy Friday. It's Mrs. Palmieri, and today we are going to talk about how to solve application problems with scientific notation. Application is just a fancy word of saying, how are we going to use scientific notation in the real world? So we're really talking about word problems today. I know most of you do not like word problems, and rightfully so. Word problems are challenging, but to make sure that you understand how to do it, the hardest part is to focus on translating. In order to do the translation, you need to be able to identify those key words and turn them into a mathematical operation. So in looking at specific words in a word problem, and then knowing if you're going to add, subtract, multiply, or divide. At this time, you should have completed watching that Prezi. And the Prezi was just a quick slideshow to talk you through the common words that you've probably heard of and seen in classes since you were in elementary school. So out of those words, I'm just going to highlight the ones that you really need to know for scientific notation. And these are the most common ones that we see. So hopefully you have your packet and you are ready to take some good notes along with me. We're going to start off with multiplication. And multiplication in scientific notation really just has two that we see most frequently. And the two that we have is of and times. And times is pretty obvious. Moving into our division, the two that we typically see is times greater and again, you should be taking notes in your packet along with me, and times smaller. Under addition and subtraction, there are a lot more. So we're going to start off with addition. So in addition, we have increase by, we have more than, combined. I think combined is something that we see a lot. Could also be together. Total. Sum. And of course added to. I think out of the ones here for addition, the most frequent that you'll see is probably the combined, in total, or increased by. You might even see the more than. Okay, let's go ahead and move into subtraction. So subtraction, we have how much less. Now you're also going to have how much more, so I'm just going to put slash more here. And it doesn't really make sense when you hear it. How much less is fine, but then how much more, and typically when people think more, they think that it's adding, but if it's how much more, we're still looking for the difference between numbers. So anytime you're looking for the difference, we are looking to subtract. Scientific notation a lot of times talks about distance. So when we have distance, we also want to focus on how much further. Especially since in scientific notation, we do look at the distance between planets, and that's pretty common. So we also have the difference between. And we have the distance or difference of. And then there's the typical less than or fewer than. Just giving you a moment to catch up on your notes as you are jotting these down. Okay, so these are the most common terms that you will typically see. And now let's just review a couple of steps. When you're going over any sort of word problems, remember that there are 4 steps to solving any word problem. And this is the first step, is when you read and reread the problem, and then you identify the factors in the problem and write them in scientific notation. Your second step is then to underline or highlight any of the keywords to indicate the operation. Remember, you're looking to see if you're going to be adding, subtracting, multiplying, or dividing. After that, you're just going to write your problem out. So you need a scientific notation, an operation, and then your second scientific notation. And then the last step would just be solving. Remember also when you are solving, there are specific rules, and they're different if you're adding, subtracting, multiplying, or dividing. But also take care to make sure that you are writing your answer in some sort of word format. So we're going to see how this is done. I'm going to work out a few of these with you, and then if you need assistance, please ask. All right, so number 1, or the first example you have, I don't think they're actually numbered. We have the average distance from Earth to the Sun is 1.46 times 10 to the 8th kilometers. The average distance from Earth to the Moon is 4 times 10 to the 5th kilometers. About how many times greater is the distance from Earth to the Sun than to the Moon? So once you've read the problem, we're going to go in and just identify. So I have my scientific notation here and here. So those are the numbers I'm going to compute with. Now I really need to locate where in this problem tells me the operation that I need to use. And the operation here is right here, the many times greater. Hopefully you looked at your key terms and you identify that, the how many times greater, and the how many times greater up here is your division. So I'm just going to make a little note right here that this means to divide. Now when we're dividing, we need to figure out which number is divided by the other number. So the way that we can do this is I want to know how many times greater is the distance from the Earth to the Sun than to the Moon. Well, if I think about it that way, and the way that the question is structured, what I'm really looking for is I'm going to have to zoom in here and watch my handwriting. I'm looking for Earth to the Sun divided by Earth to the Moon. So once I have that worked out, all I need to do is to plug in my scientific notation. So I had 1.46 times 10 to the 8th power. And this is divided by 4 times 10 to the 5th power. So remember, we are going to divide top, divide by bottom, and then you take your exponents and you are going to subtract them. So 1.46 divided by 4 is 0.365, and this is times 10, and then I had 10, 8 minus 5, which is 3. Remember, we always subtract top down. From here, remember you have to look at your first factor. Is your first factor in correct scientific notation? 0.365 is not between 1 and 10, and therefore I need to move my decimal point. So, are we subtracting or adding a space? So this would be adding a space, and this would be subtracting a space. So hopefully you were able to see that we need to subtract a space by moving that decimal point to the right. So I'm going to take away a space here, meaning I take away 1 from my exponent, and that leaves me with 3.65 times 10 to the second power. And because the question is asking about distance, I am going to also include kilometers greater. So this is my final answer. I'll zoom out for you a little bit so you can see that. Okay, our next example. About 8.73 times 10 to the 8th power people in the world speak Chinese. About 3.22 times 10 to the 8th power speak Spanish. In scientific notation, how many more people speak Chinese than Spanish? So of course I have my scientific notation here and here. And we're looking for those keywords that tell us what to do. So in the question, I have about how many more people speak Chinese than Spanish. So how many more is what I'm looking for. So we're going to go back and see if we can find it here. So how many more is the how much less slash more. So that is subtraction. And hopefully you see that. I'm going to go ahead and write out the problem. So we have Chinese speaking and then Spanish speaking. So I'm going to write, I can't write like that, 8.73 times 10 to the 8th minus 3.22 times 10 to the 8th. And now this one's pretty basic. If you remember your rules from adding and subtracting, remember that your exponent has to be the same. And if they are, you're just going to take your first factor and use whatever operation is in the problem. So we're going to subtract 8.73 minus 3.22 is 5.51, and this is times 10. And because the exponent was common, we're going to keep that in our final answer. So 5.51 times 10 to the 8th, more people. Remember, these are word problems, so we are going to answer those in complete sentences. Speak Chinese. Then Spanish. And that is your final answer for this problem.